All right. So applications of the is, we need to know that differential equations are made in many fields. We can use differential equations to determine the gradient of tangents. Gradient of tangents. We can use differential equations in the field of rates of decay. Those ones who do some chemistry and physics here, something like rate. Rates of decay, decomposition, cooling. We can use the is in rates of formation. We've got rates of formation. We can use the is. Actually, we can have here rates of formation, spread, growth. We can use this, the is in displacement, in motion, basically. Displacement, velocity, and acceleration. As we shall be seeing, we can, of course, they have got wide number of applications. This is linear motion in simple terms. So all these cases, if I'm to cut the story short, gradient of tangents, it means that you need to be knowing what a tangent is and how do you get the gradient of a tangent before you come to rates. You need to know rates of decay. When something is decaying, when something is decomposing, it is reducing in mass. So when we say rates of decay, we are looking at something reducing in mass. When we say decomposition, we are seeing something decomposing. When something is decomposing, it is still reducing in mass. If we say cooling, assuming that water is cooling, here we shall meet Newton's law of cooling. For those ones who do physics, you must be aware of that, the Newton's law of cooling. So here still we shall look at cooling basically. When water is cooling or when something else is cooling, there is loss in temperature. So here, there is a decrease in rate. Then rates of formation, when maybe something is being formed, of course, it can't be decreasing as it is forming. When there is something like forming, it means you're increasing the mass, increasing the volume, increasing something. Rate of spread, if it is coronavirus, it will not spread while reducing. Shall be like maybe COVID-19 spreads at a certain rate. So you need to be knowing that when something is spreading, it is having a positive change. The spread of a rumor, your villages, your villages better. And I don't know why it is normally attributed to ladies. However, that is a stereotype. The stereotype that ladies do rumor mongering. If we said this, the rate of spread of a rumor, there was a question in UNEB. That question, I love it very much because it clearly brought about the aspect of rumor mongering. It was UNEB of 1998. A rumor spreads through a town at a rate which is proportional to the product of the number of people who have had it and those ones who have not had it. So very, very, very interesting topic. When it comes to applications, it is very, very, very amazing. So when something is spreading, you can't say that the rumor is spreading while it is reducing. No. Instead, it can keep constant. Maybe one can say, I have told you, but let it keep between two of us, please. I beg you, don't say it. Don't tell anyone else, please. But already it has spread. Provided it comes from your mouth as the primary individual and it goes into someone's ears, it has already spread. Even if it stops there, it did not keep with you, it moved. So the rate of spread has a positive change. Then the rate of growth. The rate of growth If it is a certain bacteria, if it is culturing like bacteria, yes, the bacteria will keep increasing. If it is basically, look at it, something is growing. Maybe there is something like reproduction, something is producing this, the rate of growth of the number of animals, maybe. The displacement here, we shall also look at how best we can apply it. And now, what makes this topic very, very, very amazingly good is basically the fact that all the things are applied in real life, all of them. Some people, those ones who do mathematics to greater heights, someone specializes in differential equations and they do their research in differential equations. Someone who was very, very, very mathematical in this COVID-19 and started doing the research about the rate of spread of COVID-19, and he comes up with a manual and the follow-ups. That person would really earn money from that. Someone who looked at, who revised the rate of spread of COVID-19 and compared it with the temperature changes, someone would come up with a manual or a guideline to the Ministry of Health, and that person gets money. So all these things I've put here, they are applied in real life. I really would need to begin with this, then I go to this later. I want to begin with the 2 and 3, then after I go to gradients and tangents, then I conclude with displacement, velocity, and acceleration. So allow me say our first thing would be rates of decay, decomposition, and cooling. Rates of decay, decomposition, and cooling. Now, when we say rates of decay, something is decaying, rate of decay of a substance. So we shall here prove some of the formulas which still are applicable, because if you check like UNEB of 2014, they almost wanted to derive the formula for the rate law of the rate law with respect to radioactivity. Chemical kinetics somewhere, somehow, but let's talk in mathematical language. We are going to look at the rates of decay, decomposition, and the cooling. And I don't want to really waste any single minute, but rather start with the examples. Example number 1. The rate of cooling of the body, the rate of cooling of the body is proportional to the excess temperature of the surrounding air. Full stop. Given that the surrounding air, is constantly at 20 degrees Celsius, and the body cools from 100 degrees Celsius to 60 degrees Celsius in 5 minutes, comma, Roman 1, determine the temperature of the body after another 20 minutes. Roman 2, how long does it take? How long does it take if the body how long does it take the body to cool to 30 degrees Celsius? How long does it take the body to cool to 30 degrees Celsius? This is 12 max. If you want to find out the clarity of these numbers, you can always check the last number of the papers of pure math. You'll find that I'm not saying that it's a guarantee that it must be on the last number, but it is commonly the last number carrying 12 free max. Now, the moment they say the rate of cooling of the body is proportional to the excess temperature, come and tell me, of course I'm on number 1, come and tell me that let theta be the temperature of the body. Let theta be the temperature of the body, because there is temperature, but we need to know what that temperature is. So let theta be the temperature of the body. Then now we go back to the question and revise it. They are saying that the rate of cooling, when they say the rate of cooling, it means that the theta, the T, what is cooling? The temperatures are reducing. So the rate of cooling, we denote it as the theta dt, is proportional, right? Proportionality sign is proportional to the excess temperature of the surrounding air. Is proportional to the excess temperature of the surrounding air. What is that excess temperature? That excess temperature is equal to the temperature of the body minus the surrounding air temperature, which is 20. The moment you fail to come up with this expression, there is nothing you can pick. But they say the rate of cooling, the theta dt, is proportional to the excess temperature. What is excess temperature? Excess temperature is theta minus 20. If you're with me, type yes. When they say excess temperature, you get the temperature of the body minus the temperature of the surrounding air. So if you're with me on that interpretation, type yes. So from here, it would mean that, of course, when they say, you see the body is cooling, so the rate is negative. So you'll say d theta by dt. To remove the proportionality sign, we introduce equal signs with a constant, but negative k theta minus 20. The reason as to why I'm using negative k is simply because the body is cooling. The moment there is aspect of cooling, you really have to bring in the negative aspect. If there is decaying, negative aspect. Interesting. Now, it would mean that here we have to solve this differential equation and we have to separate the variables. So separating variables, if you separate the variables, it would mean that we shall have d theta. I've already done this work with you. So it will be d theta over theta minus 20 is really equal to when we separate the variables, now here we shall have negative k dt, negative k dt. Of course, after separating the variables, you have to integrate. So we shall have d theta over theta minus 20 is equals to negative k dt. Integrate both sides. Integrate both sides. I can say negative k, then I integrate dt. Now, when you integrate this, theta minus 20, of course, this is the derivative of the numerator. It's like 1 over theta minus 20 d theta. When you differentiate theta minus 20 with respect to theta, you get 1. So this is ln theta minus 20 is equal to negative kt plus the constant of integration. Negative kt plus the constant of integration. Remember what? Initially, the temperature was 100, meaning that before any minute elapsed at time is equal to 0, theta is 100. Bring that condition because it cooled from 100 to 60. So initially at time is equals to 0, theta is 100 degrees Celsius. When you substitute for t as 0 and for theta as 100, you can get the value of c. What does it imply? It would imply that ln 100 minus 20 is equals to 0 plus c, implying that my c is ln 80, because 100 minus 20 is 80. Now, that c, because what we really need to get the value, we need to get the value of k. So now bring this c into this expression. So by substitution, it means that we have ln theta minus 20 is equal to negative kt plus ln 80. Now, by having this, we can go ahead. After having this, of course, they say that it reduced from 100 to 60 in 5 minutes. So it means that when the time was 5 minutes, the theta now is 60. Then we substitute also to get the value of k. You must make sure that any constant you have is obtained, because we shall move when we are no longer looking for the value of k or c, but rather we shall be looking for the value of theta and time. And that's why you see they want you to determine temperature and how long, meaning that the unknowns that should keep there should be time and the theta. So what do? We shall say that at time is equals to 5 minutes. All right. When it is 5 minutes, theta is equals to 60. It has already reduced it to 60. You must make sure that you solve for the rest. So it means that ln, when you substitute there, ln 40, because it will be 60 minus 20. So it will be ln 40 is equals to, now time is 5, negative 5. It will be negative 5 k plus ln 80. Now, of course, this will be 5k this side is equals to ln 80 minus ln 40. But remember, I always tell you that ln has the properties of logarithms. So 5k is equals to ln 80 divided by 40. Since we are subtracting, we shall divide. So 5k is equals to ln 2, and therefore k is equals to 1 over 5. We shall divide by 5, so it is 1 over 5 ln 2. Now, I've already gotten k, I've already gotten c, so I substitute my value of k into this, so that the only unknown I see is only theta and t. If you're with me up to where I have obtained all my constants, c and k, type yes. This question, the moment you have understood it, it is the fastest. You can do it very fast. Very fast. If you've understood me, with how I've gotten k and t, type yes. Now, after this one, you go ahead to substitute for the value of theta, or rather the value of k and t, and we shall have by substitution, we shall have that ln theta minus 20 is equal to negative kt. So it will be negative kt. We have gotten k as 1 over 5, so we shall have negative 1 over 5 or negative t over 5, then ln 2 plus a constant c, which was ln 80, or you can rewrite this as, you can bring this on this side. You can bring this on this side, so that you say ln, because when you bring this side, it will be minus. So you can say ln theta minus 20, because you would have subtracted, you will divide. Divided by 80 is equal to negative t over 5 ln 2. Now, the challenge now is the pure mathematics that is going to come in when we are looking for theta, when we are looking for this. Okay, so that is where we need to really be smart. Alternatively, if one does not want to get it to this, because one can use this one, very interesting, or else a student, after from where we had this is alternatively, from ln theta minus 20 is equals to negative kt plus c. Okay, you check that step after integrating, after separating the variables and integrating, we have that step. So it would mean that from here, if I want to eliminate that ln, I will introduce e both sides. So it would be theta, of course, when you bring e, when you bring in the e, theta rather ln will go. So we shall have theta minus 20 is equals to e, this one now will be the power, negative kt plus a constant. A student who continues with this will be getting all the answers of time and theta still. Even this student is going to be getting them. Now here, you come and tell me that theta minus 20 is equal to, of course, if I'm adding, it means that it is e power negative kt times e to the power c. I can let e to the power c to be equaling to a certain constant, maybe capital A. Okay, so I can say let e to the power c be equal to a. So it would mean that theta minus 20 is e to the power negative kt times a. So a e power negative kt. And me, I love this approach very much. Then now you start. When time was 0, the temperature was at 100 degrees Celsius. When you solve here, when you substitute, you're going to get theta minus 20 is equal to a e power 0, which is but theta is 100. So 100, meaning that a, of course, e power 0 is 1, so a is 80. A is 80. So when you substitute here, it means that theta minus 20 is equal to A, which is 80, E power negative kt, but we also need to find out k. So to find k, you bring in another interval. When time went to 5, theta went to 60 degrees Celsius. So when you substitute, it means you have 60 minus 20, so you'll have 40 is equals to 80 e power negative 5t, for negative 5k, sorry, for negative 5k. Solving this is a half this side, so we shall have a half because we shall divide by 80 by 80. So a half is equals to e power negative 5k. But if I need k now, I will bring ln again. So it means that I will have ln half is equals to, when introduce ln here, it will just be negative 5k. So it means that still you can get your value of k. So my k still is going to be equaling to 1/5 because I will divide. All right, so I'll have 1/5 1/5 in what? Ln a half. I will have 1/5 ln a half. I guess so. So implying that when you substitute for k and for c, what is this c? We don't have c in this case. So it means that you will have your general equation as theta minus 20, theta minus 20 is equals to 80, which was a, e power negative k. So it will be power negative 1/5 t ln a half. So that is what I really have.
Master, you are neglecting the negative.
From where?
From ln a half equals negative 5k.
K is supposed to be negative 1/5. So meaning here we have positive, isn't it? Isn't it? I guess the steps are clear. So you can choose between this and this, the one you will be using to get the value of theta and t. Okay. For example, if we had to use this, the question is determine the temperature of the body after another 20 minutes. I want us to use both and you see. From here, of course, one can use after getting this or after getting this, whatever you do want to use. So whatever you do want, you be wanting to use, it is okay. But me, I prefer the second one because it simplifies the work later. So, but let's check this properly. A half is equals to e power negative 5k. Then ln a half is negative 5k. So k is a negative 1/5 ln a half. Yes. Then I bring it here. Okay. We have that. Now, from From that, they want us, Roman 1, they want the temperature of the body after another 20 minutes. Okay. So after another 20 minutes, it means that time is equals to 25, because it was 5 minutes. Now they're saying after another 20 minutes. So they want when time is 25 minutes. So we can substitute in this expression where we had ln theta minus 20 over 80 is equals to negative t over 5 ln 2. You substitute. So it will be ln theta minus 20 over 80 is equal to negative t. So it will be negative 25 over 5 ln 2. All right, ln 2. So we need the value of theta. So what do? It means that this is negative 5 ln 2. So it means that ln theta minus 20 out of 80 is equals to negative 5 ln 2. Okay. So it would mean that so this one would mean that if we bring this on this side, it will be ln theta minus 20 over 80 is equals to negative ln 32. Because this ln, a 5 will come and the power a 2, which is 32. So implying that if we are to eliminate the concept of negative here, we can take the reciprocal, because the lns are either way. Okay, the lns are either way. So it means that if we move this one up, 80 over theta minus 20 is going to be equaling to 32. That is how pure mathematics is. I don't want a negative, so take the reciprocal. Okay, so here it would mean that if you cross multiply, of course, 80 would be equaling to theta 32 into theta minus 20. Here you can get the value of theta direct. So we shall have 80 is equals to 32 theta minus 32 times 20. Is it 640?
It is 640.
So when this one comes this side, it means that our theta is going to be 80 plus 640 out of 32. So what is the value of theta?
22.5.
22.5 degrees Celsius. Now you need to know the body is cooling. So if you got like 70 really, you would be wrong, because it can't cool from 60 to 70. It has to be going down. So it means that time is equals to 25 minutes. It will cool to this temperature. And you get free marks. Then the final concept they want, how long does it take for the body to cool to 30? Yes, Nakatu.
Teacher, how did you get this 32? Ln 32.
Laws of logarithms. Ln is like log. If you have 5 log 2, it's the same as log 2 power 5. So 2 power 5 is 32.
Thank you, teacher.
Okay, then Roman 2, they want us to find how long it takes for the body to cool to 30. They need time when theta is 30. So they have given us theta at 30 degrees Celsius, but they need time. So we shall substitute ln, we're substituting in this 30 minus 20 over 80 is equal to negative t, we don't have time now, negative t over 5, ln 2. Now this is 10 over 80, that is ln 1 over 8 here. We have ln 1 over 80, this side is equal to negative t, it is over 5. Negative t over 5 ln 2. Or here still, a student who is observing it very well can really see that I can call this one, if I say wait. Yes, if I want to remove the negative, I will take the reciprocal. So it will be ln 8. It will be ln 80 is equals to t out of 5 ln 2. All right? So I can get my t here. As simple as this. So my t will be equaling to 5 ln 8 over ln 2. 5 ln 8 over ln 2. What do you get? I've just cross multiplied and made it the subject. So what is 5 ln 8 over ln 2 on the calculator? You get 15?
15.
15. So you'll tell me it takes 15 minutes for the body to cool to 30. You just reason those intervals. You can reason the intervals. When the temperature was 0 degrees Celsius, no. When time was 0, temperature was 100. When time was 5, temperature was 60. When time was 25 here, of course, the temperature also has to reduce, 22.5. Now, they want time when temperature is 30. When temperature is 30, the time will be 15. You can see that really it is working out. If you got like 20 something, I would reason you out. So you have to be careful when you're reasoning this thing out. When they say there is a general cooling, then we take that. So the second question, I'm going to do it using the approach of this other method. I want to do only this number 2 because we cannot finish all things in one day. I'm going to do only question 2 here, and then we prepare very well for the rest of the questions. We shall do very many examples on cooling, decay, and growth, because that is where the target is always. We shall do very, very many examples. But I just want you, after this question, I want you to go through and see if you can calculate it by yourself, in addition to understanding the principles of the previous work, because sometimes you find part A is what we covered at first, then part B is the application. Or basically, you find a whole number application. So example number 2, the rate of cooling of a body is proportional to the temperature of the body. Is proportional to the temperature of the body at that time. Given that the body cools from the body cools from 72 degrees Celsius to 32 degrees Celsius in 10 minutes, determine how much longer it will take the body to cool to 27 degrees Celsius. How much longer it will take the body to cool to 27 degrees Celsius. Okay. Here still, let's let theta equal to temperature of the body. But they're saying that the rate of cooling, so just say d theta dt, is proportional to the temperature of the body at that time. So now there is nothing like subtracting the excess. No. So just say to theta. Then say the theta dt, since there is cooling, is equals to negative. Introduce KT. Why negative? Cooling. Separate variables. Negative K theta. Separate variables. The theta over theta is equals to negative K dt. If you're with me here, type yes. If you're with me here now, type yes, good. Now, it is from this point that you can integrate either sides, okay? After separating variables, you can integrate. So we shall have the theta over theta is equals to negative K dt. When you integrate the theta over theta, you get in theta is equals to negative KT plus the constant of integration. Now, we need to get the value of K and we need to get the value of C. Now, I want to use the other formula. I want to use the other formula now. Otherwise, one can use the other one also. So here you can see that our theta is equal to, we introduce E, it will be E negative KT plus a constant. So our theta is going to be equal to E power negative KT times E to the power C. I can let E to the power C to be equaling to A, implying that my theta is equaling to E to the power negative KT times A. So I have that. Now, if theta is equals to A E power negative KT, then I will start. At time is equals to 0 because it cooled from 72. So that is when time was 0. At t is equals to 0, theta is 72. Substitute here. So 72 is equaling to A E power 0. So A is equals to 72. When you bring it here, we've already gotten the value of A, so it will be theta is equals to 72 E power negative KT. Then now we need also K. To get K, we use the second one. In 10 minutes, you have cooled to 32. So say at T is equals to 32, our theta, no. At T is 10 minutes. Our theta is equal to 32 degrees Celsius. Substitute it there. When you substitute it, we shall have that 32 is equaling to 72. We put here e to the power negative k, negative 10k, right? Negative 10k. But we need k. So if we need k, you can divide through by 72. So it means that 32 out of 72, which is 4 out of 9, 4 out of 9 is equals to E 10K. We introduce ln both sides. We introduce ln, this side you'll have negative 10K, and this side you'll have ln 4 over 9. So ln 4 over 9, because you cannot solve it when you have not introduced k, when it is rather when you have not introduced ln, moreover you have it as a power. So ln 4 over 9 is equals to E, is equals to E. No, is equals to negative 10k. So our k is going to be equal to negative ln. Our k is equals to negative ln 4 over 9 out of 10, or times 1 over 10, which is out of 10. So one can write it as k is equals to negative 1 over 10 ln 4 over 9. Substitute this k here, and you see what your theta is. So our theta will be equaling to 72 e power negative k. But remember, k is negative already, so it will be power 1 over 10 ln 4 out of 9. That is what we have. If you're with me so far here, type yes. Of course, I have t. I have a t there also. I have a t. If you're with me, type yes. Now meaning you can get theta and you can get t, depending on what you are given. Now here they gave us temperature, theta, they want time t. So if you're with me so far here, type yes and we see. Otherwise, even here, one can use the other formula of substituting from here without bringing the e. You can work without e throughout, okay? So if you're with me up to here, type yes. Now, I'm going to move with this expression. Yes, Nakato.
Teacher, I beg your pardon from here where you got negative 10. That step, ln 4 over 9 is equal to negative 10k. Yes, I beg your pardon.
Divide by 10 both sides to get k. When you divide by 10, you will get this negative 1 over 10 ln 4 over 9. Because we are interested in k, so that we substitute it here also. Isn't it?
Yes.
So that one will give us our theta as this, but then we need t because they have given us temperature. So when theta is equals to 27, it means that here we shall have 27 is equals to 72 e power negative 1 over 10 t ln 4 over 9. However, someone can use that approach of bringing in the values here so that we substitute for c without going this far. So that I wanted to do you either. So here we have this, meaning we can divide by 72 both sides. So you'll have 27 over 72. Let me take it this side. We shall have 27 rather, out of 72 is equals to E 1 over 10 t ln 4 out of 9. This is the same as, here you can introduce ln, but this one, before I introduce ln, this one is the same as, I can divide through by 7. So it is 3/8 ln, no, 3/8 first, okay, is equals to E 1/10 T ln 4/9. Then now, since what we need is in a power thing is a power, because we need T which is a power, so we shall introduce ln, meaning when introduce ln, this side will be ln 3/8 is equals to, when introduce ln here, we shall instead have a fraction. So it will be T, we shall neglect the power. So we shall have T/10 ln 4/9. Practice makes perfect. We are going to learn these things. So, meaning that our T, to get T, of course, we cross multiply. So to get T, it will be equaling to 10 ln 3/8 divided by ln 4/9. This one will give you the time 10 ln 3/8 divided by ln 4/9, it will give you 12.1 minutes. Or since we can record it as a whole number, which can be approximated to 12 minutes. But the question is, determine how much longer. So to get how much longer, they need extra time. You need extra time. Someone is like, how about the negative on the power? Which negative? Because the value of K was negative. And in the formula, we were to substitute where there was a negative. The negative cancels to a positive. That's why I'm like, go back through and see how it generates to be like that. You're going to find it very, very, very clear. Because my K was -1/10 ln, my K was 1/10, -1/10 ln 4/9. But the expression where I'm going to substitute, there is also negative T something. So when it goes there, it will become positive. Okay. So our time is 12 minutes. Meaning, if we are to get the extra time, the extra time will be equaling to 12 minutes minus the 10 minutes. 10 minutes are given in the question because they said that given that the body cools from 72 to 32 minutes in 10 minutes, determine how much longer will it cool to 27. So it will take extra 2 minutes to cool to 27 degrees Celsius. Now, these things, because we've studied them today, our next lesson is going to bring the clarity of all these things. We are going to have the clarity of all these things. I want to go beyond this, go through those 2 examples we've done, do them. Now, like this number 2, do it using the other method and see if you get the same answers. Then we start from there next time. I wish you all the best.
Thank you, teacher.